welcome everybody to this episode of Mind the Data Gap podcast. Today we are going to have a very special guest, a legend in the data science and machine learning communities, Vincent Granville. Vincent co-founded Data Science Central, which is an absolutely massive portal about data science and machine learning. He currently leads machine learning techniques forum as well, which is extremely popular in machine learning and data science. Really looking forward to discussing the topics of around synthetic data. So what synthetic data is, the problems it solves, the benefits, the value it delivers, and also some historical context as well, which is extremely interesting given Vincent spent over 20 years in corporate work at eBay, Wells Fargo, Visa, Microsoft, NBC, and others. He holds a PhD in mathematics and statistics, and he's a former postdoc at the University of Cambridge in the Stats Lab. So really wanted to record this one for some time. So welcome. Shall we start with a quick round of intros? Simon, do you want to quickly introduce yourself?
Hi, Vincent. Hi, Nicolai. My name's Simon. I'm a machine learning lead at Synthesized. And through my role there, I look after the development of and sort of frameworks of deep generative modeling. And always looking at how to best apply them to the finance, insurance, and healthcare industries. Prior to that, I worked as a machine learning engineer in the legal and healthcare sort of industries, and I guess before that, I studied physics and natural language processing.
So I earned my PhD in mathematics and statistics in Belgium in 1993. Working on computational statistics, moved to the Stats Lab at Cambridge to work on a postdoc, which I finished in North Carolina. Then I moved into the internet industry, worked for a number of companies, did some consulting on companies like, for instance, Wells Fargo, Visa, eBay, Microsoft. And eventually I created Data Science Central, which is known as a very popular community for machine learning practitioners. In 2020, it was acquired by TechTarget, a publicly traded company. And right now I'm trying to restart something similar, which is machinelearningtechniques.com. So that's a brand new website.
And by the way, Vincent, in terms of like this podcast, so we obviously started working on synthetic data with the team, and have been really working a lot on the generative modeling, like different techniques to generate synthetic data. And then we published this article about applications of synthetic data in machine learning. And that's, I think, how we started the conversation with you online. And that's essentially what led to this podcast. I was genuinely really interested in understanding what led you to become interested in synthetic data.
Probably I've been working on synthetic data. It was not called synthetic data. You might call it simulations for a very long time. Maybe at the beginning it was just simply creating, random numbers, but using some original techniques that were based on irrational numbers and stuff like that, rather than the typical congregational random number, pseudo number generator. Over time, since I've been working a lot independently, for instance, for Data Science Central, I found that I just could create a lot of data. Then there's also the fact that I have a significant interest in number theory, and not the theoretical number theory, but what is called experimental mathematics or probabilistic number theory, which essentially it's a lot of experiments like machine learning. Sometimes I mention, my data sets, actually, everybody is talking about huge data sets. I'm saying my data sets are infinite. And they really are. I'm working complex numbers, all sorts of objects in mathematics. I send you a link to some orbits of the function relating to the Riemann zeta function that produce some very interesting point patterns. And because it's based on mathematics, the nice thing is, what's behind it. You can benchmark some, statistical models to confirm some assumption. In that particular example I'm referring to, it's unusual in the sense that it's related to the Riemann hypothesis. So there's still a lot of things that are unknown. The shape of some holes, the overlapping of the clusters, and stuff like that. Some of the stuff is known and some is conjecture.
And by the way, you spent a lot of time at Microsoft, Visa, Wells Fargo. Have you interacted with synthetic data in the corporate world? Because of course, and I agree that in academia, so synthetic data roots really to like bootstrap techniques, right? And even before, people were simulating data sets, like point processes, like various ways to simulate data, and then run experiments on that. But I'm actually curious, in terms of your experience, at corporates, did you interact with synthetic data at all, or?
I could have been something of interest. For instance, when I was working at Visa, that was around 2005, something like that, because the problem was to identify fraud in real time on credit card transaction fraud, and there was like 4 transactions out of 10,000 were fraudulent. So the data set of fraudulent transaction was small. It's like 50 million transaction. It's not that small, but small compared to the whole data set. So back then we didn't use the synthetic data. We were kind of rebalancing the data, and so it's probably why suddenly synthetic data has become much more interesting and valued these days.
Very common example, Simon, what you probably see with working with customers as well, huh?
Yeah, definitely. It's I guess one of the main use cases we're seeing at the moment at Synthesized is really dealing with these heavily imbalanced data sets where there's only a very small number of actual fraudulent transactions, and machine learning engineers are needing access to more data to try and produce more robust and reliable models. It's interesting that it's only just starting to be used, I guess, given this problem's been around for such a long time.
Yep.
And I think what's interesting is this use case is actually slightly orthogonal to privacy use case, which currently synthetic data is mostly used for, which is, okay, we want to create this kind of sample which is privacy preserving and can be used in sharing between teams, but rebalancing is actually not really even related to privacy. It's more about how we can improve the efficiency and prediction performance of a given model, reduce uncertainty on this class, right, on this underrepresented class, and basically kind of really be able to quantify risk, reduce uncertainty, and that's basically a very common use case. And Vincent, by the way, in terms of other applications and problems, what problems, in your opinion, does synthetic data solve?
One that I've seen recently, it's with the example with digit recognition, so handwritten characters like 1, 2, 3, and so forth. So there's this famous data set called MNIST with, I believe, 60,000 images representing handwritten digits. If you incorporate synthetic data, so these are going to be, in the end, it's going to be images with, kind of handwritten numbers, but written by software, in the sense that eventually it's a clustering problem. It's simple, actually. I'm talking about one of the simplest example of where clustering in synthetic data has been successful. You can add a lot of digits that nobody would handwrite. So you're going to enrich your data set considerably, and allowing, in principle, to when suddenly you get someone who has written 3, for instance, but the way it was written is kind of awkward. the training set cannot match it. But the synthetic data might be, because if it's well designed, it's supposed to be much richer, will help. And actually right now there's something that's people talk a lot, which is augmented data. And augmented data is blending actual data, like the observations, the training set, with synthetic data. And that seems to be what is working best and getting some success these days.
Simon, like you obviously interacting a lot with customers and companies in the UK, Europe, US.
Yeah.
Do you see common patterns in terms of the problems synthetic data solves?
Yeah, definitely. I think in the sort of scenarios where the privacy of the original data isn't an issue, then we're sort of seeing, all right, well, what can synthetic data add to my original data? I don't need to just work within this synthetic framework purely. Instead, what else can I do to my training data to really enrich models? And I think it raises a couple of questions sometimes within the machine learning community. People often, I think, get a bit confused if you've got some original data, that contains some original information. What's adding synthetic data that's been derived from the original data going to do? Where's the new information being added into this sort of system? How can you use synthetic data to improve the performance of a model? It's an interesting question, especially when you try and think about where, I guess, the original information source is. But I think the way I see it is that synthetic data enables you to reshape, and augment your original data, and it allows you to, I guess, amplify the signals of information that your machine learning models are using, for their classification tasks and so forth. I don't know if that's the same sort of way that you see it, Vincent, in terms of, if you're not doing anything like transfer learning when you're creating the synthetic data, there is always that question of what extra information are you supplying to your model?
Yeah. So one thing also I would like to add about the value of synthetic data, and particularly in my case where I try to develop a lot of new and testing new algorithm, is benchmarking. When you have a training set, you're going to split your training set into two parts. There's the validation, or for which and you use the validation as if you didn't know the answer, and then you can check whether your predictions how good they are. And in one example, I found that it's an example that you mentioned, Nicolai, in a recent paper, in the case of regression, when I'm trying to create synthetic data where the feature have a pre-specified covariance matrix that's the same as the training set data. And so there were different kinds of regression techniques that I tried. There one that's more like a kriging, which can provide incredibly good. It's kind of an interpolation technique, actually. So on the training set, you can provide exact prediction, and as you would expect, on the validation set is going to work much less. But the problem also I found with the more kind of classical type of regression is that on the validation set, the performance was pretty much the same as on the training set, and I was surprised. I would expect a drop in performance. So I found that this kind of a flow of my synthetic data. Now, how to make the things better and more rich in the synthetic data is to use a lot of parameters that allows you to create various type of distribution. So there's a noise in order to be more realistic. For instance, a quick fix to get a more realistic situation in that case with my synthetic data, I just simply increase the amount of noise in the validation set compared to the training set, and then I experience a loss in the quality of the predictions, which is expected and more realistic. Now, I also, some of the issues I see with my synthetic data in that particular case, made assumptions of independence assumption. The observations are independent from each other. The variance of the noise is constant. So in order to really create good synthetic data, the next step, you have to, create data that has the same flows as the real data. The variance changes based on observation or group of observations. The assumption of independence is violated. The Gaussian assumption is violated. In my case, I didn't even use Gaussian assumption. I used logistic distribution and some other distributions, but I was using just pretty much the same distributions, which also brings to another thing. Are you going to get more rich synthetic data by trying tons of Cauchy distribution, logistic, Gaussian, uniform, you name it? You have to be careful about model identifiability. In a sense, you might create data from two apparently quite different models, but it eventually generates pretty much the same. From a statistical point of view, it's indistinguishable. In statistical term, it's called the identifiability issue of a model. So to make your synthetic data richer is not that obvious. You cannot just say, oh, I'm going to have 1 million parameters in my model. I'm going to use tons of different distributions. In one example, for instance, where I use, instead of a mixture of Gaussian distribution, actually use a superimposition of point processes. It's not that different. And there is an underlying density, like the Gaussian that creates the ellipse, but except the Gaussian I've used, so the uniform, it's in 2 or 3 or 4 dimensions. I'm simplifying here, but there are essentially 3 types of distribution that produce really 3 types of different kind of data. The Cauchy with this very thick tail, uniform, and logistic, which I could change the logistic to Gaussian or anything, it would barely make any changes. So that's one of the issues with synthetic data, is how to make.
Yeah, I think you mentioned this kind of element, which is essentially we bootstrap data to create tighter confidence intervals and confidence sets. Like historically and very often, bootstrap would be used to create like very tight confidence intervals, right? And we would indeed want the samples to be independent, but following the same, obviously, kind of correlation matrix. And that's been, of course, a challenge when data set becomes very high dimensional. So it's very tough to create synthetic data automatically when the dimension of your data is really high. And especially when you don't have too many data points which describe that phenomena. So you really need to think very deeply about, so how we even understand those correlations when the sample size is very small, and how we actually create synthetic data to build confidence intervals when the sample size is very small, like smaller than p, right? So then we think about like sparsity, we think about like effective dimensions, and it's a kind of huge topic and super interesting. But in terms of your corporate maybe experience, so we talked about fraud detection. So what other maybe, say, 5 most valuable or common data sets you've seen in the past where synthetic data may help? So fraud detection is one, and I fully agree. We see it as a lot in banking, in insurance. Fraud detection is a problem. So with one customer, actually, right now, we help them improve the performance of the fraud detection system by 15%. With some of the metric they use for the fraud detection system, and I think using some deep learning methods there as well. But it was crazy. So 15% uplift of the model with synthetic data. So of course, it's super valuable. But I'm wondering, like, what other valuable data sets or use cases have you seen where synthetic data may help?
Well, actually, I'm talking right now with one of the former VC guy who founded one of my past companies, and right now is involved with it's also a financial company, sure, but what they are trying to do, so they collect data about accidents, health issues, and stuff like that in order to recover money. So this can go to courts, lawyers being involved. In the end, the goal is to try to get some amount of money to the victim. So what this VC guy is doing, he pays upfront the victim based on the fact that somehow he is going to recover the money. So I don't know if there was a loan being involved in that, but in a nutshell, there's not that many cases. There's a lot of cases where the dollar amount is small, it's kind of run-of-the-mill routine, 1,000, 2,000. Some are bigger, maybe like 20,000, and they are much rarer. So I imagine that's a kind of situation where being able to create cases, a variety of different cases, and there are a lot of possible injuries, or you can imagine it's not a straightforward problem. So that would be a situation where synthetic data could help. There's not a lot of observation. There's also massive privacy, issues you can imagine. So that's an example.
Okay. Yeah, I think the issue, I guess, privacy issues is this other sort of side of synthetic data, or that this other sort of set of solutions that synthetic data can offer. Some way to approach. You see, I guess up until recently, a lot of data that's confidential is dealt with by you either don't touch it and you just leave it, or you mask it and you have to go through compliancy and regulation or sort of compliancy approval before you can get access to it. And it has to be masked and all of this. It's interesting though that even with these masking processes, that sort of data is still susceptible to various sorts of linkage attacks and inference attacks. And so we've seen that synthetic data can be used to assist with data privacy, because we're sort of removing this one-to-one mapping of the original data to the masked data. If it's synthetic data instead, no one row correlates to some original person in some data set, and so more and more it's being considered to be used in the healthcare industries, and I guess where legal data is involved. I imagine it's something similar.
Yeah, something that I like to add, Nicolai, you mentioned leakage in one of the email we exchanged, and I was looking at Kaggle competitions. There was one of a competition where you were supposed to predict cancer or something like that. So with a bunch of observations, there was a feature that was the hospital ID, which was encoded. So despite the fact that this was encoded, actually the people who won, if I remember correctly, they won based on that ID, the hospital ID, to make their predictions. And the reason they won is kind of awkward. So it was a fantastic predictor of cancer, because a bunch of patients were sent to specific hospitals, especially when the situation was really bad, when they really had cancer. So having that hospital ID attached to your name was an excellent predictor of you having cancer. So this is an example of leakage that synthetic data should, fix easily.
No, 100%. And in general, anonymization is not safe. So companies think of, I'm going to add some noise to my data point, and it's going to be very difficult to recover it. Well, not necessarily. So it really depends on the background information I have about this data set. It depends on many other parameters. It depends on the other data points in this data set. And even so, we see some techniques such as cell diversity, key anonymity, differential privacy, but even there is a huge difference in terms of theoretical maybe elements in terms of, okay, there is some epsilon and delta in this differential privacy algorithm, but also there is a simple question: can I recover original data set? And kind of in your case, you can basically just look at this data set and basically recover, oh, I can actually link it to the original data point. And there is a still kind of really, and well, it hasn't really been resolved in the anonymization world. And that's why synthetic data solves that by creating completely new environment. So as opposed to trying to mask and think about how to mask specific data point, we create completely new world. We can create completely new simulated environment, and we basically can tweak it so that create completely new patterns, like you mentioned, fraud patterns, like maybe churn patterns, maybe some patterns of like really kind of underrepresented classes as well, which is extremely important in many topics. And this problem cannot really be answered by anonymization at all, and let alone it's not secure. But yeah, that's privacy is definitely one of the important topics which synthetic data does address really well, apart from rebalancing. And we also, by the way, we see a lot of demand for the like algorithms to generate synthetic data, and we released the version of the product on our website, so it's basically for free. Everybody can generate synthetic data for free on our website, and to rebalance data, to anonymize data, bootstrap data, and also check things such as fairness and mitigate biases in datasets as well. And we believe that that component should be free, so everybody can just go there, and we'll put the link in the description and like check it out and see how it actually works. So we use like deep generative models to create and, as you mentioned, understand correlations in data and then encapsulate that into a synthetic data set. So you can create confidence sets, you can bootstrap data, you can improve the performance of your models, and all of that is basically for free. So we really want this to be used by the community a lot. So, but yeah, so, and we see actually companies looking at this and from various fields like finance, healthcare, government, like different startups as well. So normally where either data sets are somewhat privacy kind of, where basically you need to deal with privacy elements, or where data is not sufficient enough. So you have some underrepresented groups and you really want to bootstrap or understand how to basically make the data set more balanced, because nothing really impacts your model that badly as an imbalanced data set and really poorly organized training set. So it's very, very important to be able to rebalance it efficiently. But in terms of market trends, so Vincent, you obviously get a lot of exposure to different directions, fields, topics, trends in the space right now. What is driving interest to synthetic data right now, in your opinion?
It may not be that difficult to generate. You can create a lot of additional observations. It enriches the model. It applies to many different fields. One example I didn't mention is operation research, supply chain, for instance. When you have product lifetime kind of statistics, you're going to do a test and wait until some product fails. Can take 2 or 3 years. It's very costly to do that. So that's another example where synthetic data could be used. Also, I think that the name synthetic data, some people call it fake data. I like synthetic data much better, but it's been used quite a bit in the past, and the word was like simulation or some other things, and it's just that now like some of the AI stuff that you see now is very popular, originated 50 years ago, or something. I was, for instance, looking at shape recognition, which is another topic of interest, where I created lots of synthetic data. It's related to the problem of identifying digits 1, 2, 3. But let's say that instead of 10 digits, you have the alphabet. Suddenly you have 26 letters. Now let's say you're trying to identify shapes instead of 20. Chinese alphabet, and then something with millions of shapes. You are trying to identify two shapes that are almost similar, and in my case, those shapes are, and I can provide a link to the article, they're produced by a mathematical algorithm. So if two of these shapes are exactly the same or not, and some can be pretty similar. So the synthetic data in that case not only enrich and allow you to check your clustering algorithm not just on 10 digits, or which is very easy, or on 60,000 Chinese characters, but on millions of shapes. Anyway, I'll send a link to this article. What I was trying to say is that it allows you to detect weak or very weak signal. So that's another strength of synthetic data.
And Vincent, do you think people fully understand what synthetic data is? So you mentioned, fake data, synthetic data. Do you think people fully understand what synthetic data means and what value it conveys?
I don't think a lot of people truly understand what it means, how it's being generated. It's become a hot, kind of keyword. So people.
So how would you explain what synthetic data means, and in very simple terms?
Well, I would say data that's created by an algorithm as opposed to being collected from observations, and that is designed in order to emulate real data.
Yeah, I love it.
Yeah, I think as a physicist, I resonate with this idea of synthetic data being data that hasn't been directly measured. So I think you said observed, and it's that same sort of idea. I think it's very powerful once you consider moving away from only using direct observations. You can then you can start to do anything with the data that you have at hand. You can start to reshape it and manipulate it, and I think people often forget that as soon as you start to do that, that is synthetic data. Synthetic data as a concept is just modified data.
Yeah.
And also, I like to think of data as so there is a difference between data and information the data conveys. So think of data as a container for the information which is out there. So I can think about something and I can write it down on paper, and then it becomes data. And you can always think of that as, and now I can send this paper to you, Vincent, I can send this paper to you, Simon. So I'm going to transfer my data. But in fact, it's information which is from, I just created and put this on paper by means of data. And then if you think of that, you can put the same information on paper in different ways. You can actually put it in a very nice handwriting. You can put it very concise. But you can also create really badly organized data. So if you basically write it with really bad handwriting, you really don't really follow the structure. It's not really elegant enough. It's really messy. So you can create very messy data. And I think...
Well, now that you mention information, one thing I'd like to add before I forget about that is metrics like entropy or stuff that are information related to measure the quality of the richness, essentially, of the. But that's another topic that
100%, and you exactly mentioned. So it's a huge topic in statistics, as you know, right? So how I can encapsulate that information really, really well, right? So we have a number of studies by Vapnik, Chervonenkis in statistical theory. We have a number of studies in mathematical statistics about it, how to best incorporate and how partition the space so that we fully represent it. So it's a fascinating topic. And if you think about it, so then data becomes really a medium for the information which it conveys. And then you can think of, if it's the medium, it should have some parameters. But if it has some parameters, I can optimize them. And then you can create actually an optimal configuration, which becomes your container, which can become synthetic data. And that's exactly what you mentioned. And I really like your explanation, which is it's basically the data which is created by an algorithm. And then you can actually, depending how good the algorithm is, you can incorporate the information better in an optimal way, optimizing those parameters, whether those quality, whether those privacy, whether those compliance requirements. But you can actually create those kind of optimal configurations, and then you can share that kind of piece of paper better. So you can basically have a very elegant interpretation of the information, then you can just share it and distribute it in a meeting those requirements. And yes, you're exactly right. So which is, it's very much connected to the entropy studies and what's the entropy of this information, how I can actually encapsulate this, because you can ask this question, okay, if it has some parameters, what's the minimal possible shape that this information can be contained in, and so that I can actually share it without losing any information. Because you obviously don't really want to have redundant data set. You don't really want to have, and this is where we touch on PCA and many other things. But if you think of a huge piece of information, you don't really want to encapsulate it. Who knows? Maybe you can encapsulate it in a very nice package, and then you can basically kind of communicate that package, or you can basically still put it in a very badly organized shape, and that's not going to be ideal. Anyway, this is a fascinating interplay between information and data. So,
but Nicolai, it touches on perhaps another issue with data that synthetic data can help to solve, and that's sort of even just data representation and data storage. We have this increasing amount of data, that's growing in the world, and it's getting harder and harder to run all of your tests or train all of your models with huge amounts of data, and so there's also this move of looking to create optimal data sets, or these sort of golden data sets where you've got everything that you need captured in as smaller as container as possible, and that's much easier to then manage and look after than some huge data lake of information that's sort of scattered throughout many stores, or all of which sort of barred by compliance or sort of security restrictions to even access. The smaller you can get that data, the better.
Yeah. One other thing is a topic that's becoming pretty popular right now. It's called wide data. I guess you've heard about that. As you might have like 200 observations, and you have 1,000 features. So synthetic data can add a lot more observations with a large number of features, so that at least if you do some kind of regression or stuff like that, you're not in this situation where you have much more feature of an observation, which in some algorithm is going to create problems.
Mm-hmm.
No, yeah, 100%. And by the way, we also see many actual financial institutions, like really big financial institutions, moving away from sharing data to sharing models. And this is a really interesting shift we see. So especially for application development tasks in enterprise, you can just work with the model. So think of this as I give you a generative model of this phenomena, of this data set, and you can query it. So you have an API, you can query this API, get a data set, and start developing against it. You don't really need to have access to original data. You need access to the information and the correlations. And then, Vincent, as I mentioned, so once you have access to being able to reproduce data following the same correlations, if your model is good enough, you can actually use that. And that's exactly what we see with many companies right now, which is companies actually often try to use models and sharing models for development and experimentation purposes, which is super interesting. Mm-hmm. By the way, what's your view on, I guess, like challenges in terms of creating high quality synthetic data, and challenges overall in terms of communicating and sharing synthetic data as well?
One of the challenges, as I mentioned, is to make sure that your synthetic data is rich enough and not be misled by the fact that, I have 10,000 parameters to fine-tune my data set. I can use whatever distribution, which is some kind of a infinite dimensional parameter. Still, you can end up with poor synthetic data. So I think that's one of the main issues, at least in what I've been doing so far to generate this synthetic data. Then now, in order, if the data consists of images or videos or stuff like that, how do I produce synthetic data? This has been done actually. Even myself, I've done a bit of it with my shape generator, but this is kind of data that it's not tabular, it's not an array or something like that. There are ways to do it by using some models. So you have a number of parameters that summarize an image or stuff like that. That could be, next step 2 is not just generating simple arrays of data, but much more, email maybe, text, synthetic text.
Yeah, I think there is a very interesting stats from Gartner saying that more than 60% of all data by 2024 is going to be synthetic. What do you guys think?
Well, I've read, I think it was a few years ago, there was some news that were kind of synthetic in some ways. I mean, they really corresponded to actual news, but it was written by a bot, and it was terrible. I mean, you could easily. So how do you do something much better than that?
This idea of I guess synthetic text generation, it's difficult. I think it's very it's a much more challenging goal in synthetic data to create this realistic text, but it's definitely come a long way. I've seen lots of I guess image captioning, automatic image captioning, for instance, and even the other way around, where you have an automatic image generation based on some image caption. Very sort of interesting elements, but much more difficult to use because of these privacy issues associated with them. At least in sort of in industry, I think.
Yeah, and Simon and Vincent, in terms of the, I guess, criteria for synthetic data. So, Vincent, what do you think? How do you measure the accuracy of synthetic data, and what maybe other parameters would you think of to measure synthetic data in general? So, you have some synthetic data set. How do you know it's good?
There are different ways to do that. Probably one simple, easy way is you don't use any. Well, your synthetic data is based on your training set data, but now you're going to do a test where you make predictions on your actual observations, on your real data, but the model is trained purely on the synthetic data, and you see how it performs. So you can blend using some of the training set and some of the synthetic data and see how it performs. This might be the most obvious way to see how your synthetic data is performing, a metric of quality. Like we discussed, to see whether it's rich enough matrix related to entropies could be useful as well. That's the main 4 that come to my mind to answer your question.
Yeah. I kind of think it's definitely the most logical way to assess the quality of your synthetic data is looking at, well, what am I using the synthetic data for, right?
No, go ahead.
Thank you. All I was going to say was, we could use, statistical measurements and compare the distributions and see how, I guess, the distances between the distributions. But the reality is, the synthetic data is created for a purpose. Does it help with that purpose? If it's improving the performance of some model or whatever it may be being used for, then I would say that would be the best measure of its quality.
Yeah, I agree.
And we also see a lot with companies that normally, as you mentioned, so can this data set be used for my specific purpose? So whether it's training this ML model or creating a number of data sets for the so-called data hub or some kind of a space for innovation. So making sure that we can generate those also in terms of the time very quickly, in terms of compliance requirements. So there are additional when you work with clients, there are also those additional criteria which we normally kind of meet in terms of the like how long it takes. So in our case, we can basically, with the product which can be seen online, it basically takes just 10 minutes to create a very high quality representative data set. Say if it has, say, 1 million rows and say 100 columns already in one data set in the cloud. But of course, it depends on the infrastructure. We can change it slightly. And it basically, there are like enterprise components come into play. So when you move this to production, but yeah, ultimately you're right, which is making sure that the data can be used for a specific task, say uplift of a fraud detection model. So we recently, as kind of we mentioned, we helped, I think at least 2 or 3 companies just very recently to uplift their fraud detection models very, very quickly. And the performance was incredible. So we definitely see that. But also ultimately it's important how quickly, how robust the algorithms are, how robust the software is. And yeah, so we basically been working a lot on those kind of components in terms of the robustness, accuracy, speed of the software as well.
Yeah, it's good that you mentioned how hard it is to generate your data and the speed, the accuracy also of the models. I didn't think about that. And thanks for mentioning.
No, yeah, 100%. And then also, like, huge topic we are doing right now is think of, table is fine, and we've done tables, like really excellent tabular data generation at speed, at scale, automatically. But now think of a database. So think of, like you've got this kind of Postgres database, Oracle database, because we know that tables, they ultimately stored in a database. And then the question, can you generate the entire database? And now you need to think of not only correlations within one table, but also correlations between different tables. Foreign keys, primary keys, making sure referential integrity is preserved. So we've made a lot of progress and released recently a number of components as well, where we can generate the entire database at speed, meeting quality requirements in terms of referential integrity, making sure foreign keys, primary keys are preserved, correlations are preserved. And it's not easy, but yeah, so Simon is here, so really kind of huge kudos to the kind of ML team for making that sort of breakthrough in terms of database generation. That was quite incredible. And yeah, so now we're able to generate like huge databases at speed, at scale, with up to 100 of tables with complex dependencies and different referential integrity as well. So that's something super exciting that the guys released recently as well.
Yeah. Now that you're talking about correlations, one topic we didn't discuss is time series and autocorrelated time series. I mean, with synthetic data, what you could do is amazing. I mean, in Brownian motions, I can go on for a lot of time. Clustered Brownian motion in 2 dimensions. You would not even imagine that some Brownian motion would generate strong cluster structure. They're not supposed to act like that. You imagine time series that are smooth. They use a metric like the Hurst exponent that tells you, how chaotic it is versus how smooth. You can incorporate very long range autocorrelation in your time series or short range. I mean, the potential is huge.
Yeah, I mean, it's sort of I think it extends into text sort of text generation is, I guess, another form of this sort of time series, but just sort of looking at it under a different light. I think once you move into synthetic time series data, there's just so many different options for what you can do. In some sense, forecasting is just synthetic, I guess synthesizing, but just in a new time period. And you can backcast as well, and you can or sort of synthesize data in the same time period as your original data, but with, I guess, different subjects or different samples. It then becomes a whole new game, I guess, for synthesizing. I think it's that's a very exciting space now for sure.
And which brings, you asked me what kind of customers could use the synthetic data. Obviously, I'm thinking about those time series. I mean, Wall Street, is an obvious, potential client.
Definitely.
We recently actually incorporated in the software as well. So we currently support time series data generation at scale. So it's super fascinating development, which the guys have recently released as well. So quite excited about it. Cool. No, that's Yeah, that's really, really exciting. And another thing, by the way, which we also look at is data coverage. So it's basically a new concept which we often see. So it's basically related to this Vapnik-Cherenkis dimension, but making sure that we're able to cover all kinds of dimensionality with synthetic data. So even if it's not covered with original data, but we're able to extrapolate and understand how data should look like, but to be able to cover like all kinds of criteria. It's kind of related to maybe what we see in images and in kind of self-driving cars even, right? For instance, Tesla, right? So we wouldn't really necessarily be testing a self-driving car on the roads of San Francisco, on the roads of Seattle. That would be really not ideal. So what you normally do, you create, as you mentioned, a simulated environment, and then you test the different behavior of your self-driving, of your engine, machine learning engine in that simulated environment. And then once you've got the simulated environment set up, you can actually create different behavior. And this is exactly to cover all kinds of parameters and all kinds of situations so that you're able to test against them better before the car is actually put on the roads of San Francisco or Seattle, right? And this is actually what we see in structured data as well, so that we're able to understand like those elements like such as coverage of different scenarios and how to basically make sure that we cover against them as well. So that, in fact, synthetic data becomes actually better than production data in terms of covering those scenarios and being able to test against them before those scenarios happen in production, which may ultimately cause incredible huge cost to the business and incredible huge damage to the business as well, which is not ideal. And yeah, this is quite interesting development in synthetic data and what the guys have been working on as well.
Now, I guess one area of I guess use cases for synthetic data we haven't touched too much on is data bias. So I maintain a repository called FairLens, and it's an open source sort of software, and looking at the different sorts of I guess statistical ways to measure and assess bias in different forms of data. In terms of actually using synthetic data, I'd love to hear your opinion on how you think synthetic data can be used, to help combat biases within data. I don't know if it's something you've seen much of at all.
Yeah, that's not a topic I really worked on, but it's well known. It's an important things. I've heard more of bias in the algorithm that process the data. That it's some rules that maybe are going to favor. Eventually, it shows up in the data, like why some people get along more easily than others, and you see the same bias in these automated decision and in the resulting data set that because in the end these algorithms have been written by human beings, even if it's automated, so you see the same bias. You would think that you could generate synthetic data that would avoid those bias and that would show in an ideal world with few or as little bias as possible how would the loans or whatever it is be allocated and how different from the reality things could be if bias was removed.
Yeah, definitely.
That's a very good point, that there is a slight difference between algorithmic bias and data bias. So algorithmic bias, think of deterministic algorithm, say rule-based algorithm, then it can inevitably, unfortunately, introduce some different biases in the way predictions are made. But there is also a data bias, meaning that there is a discrepancy in terms of the distributions for different underrepresented groups and how those distributions are actually different when we think of the entire data sample. And we really don't want that. When some underrepresented groups, for some reason in the data set, there is a difference in, like, just think of this as an unsupervised learning. So we think of, we have overall like high dimensional distribution, but then we think when we project that distribution onto a kind of a class, and that class may be underrepresented, the distribution is different, and we should never allow that. And now the problem is, and this is what companies right now understand, is that data goes not only to machine learning engineers. Machine learning engineers, okay, we develop some algorithms, and they hopefully test for biases. Of course, we're doing a lot of work with the team to encourage people to test for biases, but at the same time, they at least know how to test for them. At the same time, think of those data sets which are heavily imbalanced against underrepresented groups going into test engineers, going into marketing teams, going into sales teams. And those are not ML engineers. They don't necessarily have algorithms to test for biases. And actually, they use those data sets to potentially make decisions. And that's really, really not great. And we work a lot to, so basically Simon and team, they released the world's first open source project for identifying biases in data and also mitigating those biases by means of synthetic data. So you can actually use synthetic data now to rebalance those underrepresented groups and make sure that there is you treat everybody equally. You treat everybody in the same way you treat the overall population. And this can only be done almost with using data rebalancing. And of course, synthetic data is a great application in terms of rebalancing those groups and making sure the data set is representing all groups, even if they're in the original data set are underrepresented, can be represented really well in the synthetic data set. And this is what this project is about, which is really fascinating. We are going to put a link in the description. But yeah, so we basically really trying to contribute a lot to this topic and release a number of open source projects as well.
Yeah, certainly just trying to improve, I guess, the state of bias and fairness within data. I think it's a difficult goal to try and resolve bias and fairness, and whether or not you can is maybe even maybe it's not even possible, but you can certainly, I guess, look at ways in which you can use synthetic data to change the original bias data that you're working with in the first place.
Yeah, I could imagine in the future a potential lawsuits or investigation by lawyers where you have to compare your actual observations with synthetic data, which are supposed to be perfect or unbiased or good, and decisions could be made based on how far, how much bias is found compared to the synthetic data.
Yeah, definitely.
Yeah. So Vincent, so it's been absolutely fascinating conversation. So thank you so much. So we just wanted to finish this with a quick fire round. So I'm going to ask you just quick questions, and please, you can just give very short answers. So what's the most interesting topic you are looking to cover in your blog in ML techniques?
Actually, synthetic data is one part of it, and then there is some other thing I'm focusing, which is explainable AI, interpretable machine learning. So designing a system, they can look very similar to very deep neural networks, but in using weight that you cannot interpret. You have no idea. I mean, you get an answer from the black box system. Getting an answer that's much more easy to interpret, and this is becoming a very hot topic.
Okay.
So, yep.
What are 3 favorite machine learning books about machine learning?
Oh, I published recently a new list of more than 10 books that are very modern and very popular. One is called probabilistic machine learning. I think that's the title. That was one that I really like. Then there is, of course, the Trevi and Asti book. They published a new edition in 2016. So these are 2 books that I like. I found that there's many books that are self-published now. They're much less academic in style, and I liked it quite a lot. It comes with lots of Python code. I can share you the link with those books that I mentioned that are much more recent.
100%. We'll put it in the description as well. And what is sort of I guess most interesting releases or events you're looking forward to this year? So maybe some kind of events, maybe some releases of some interesting software. what are you kind of looking forward to this year in machine learning?
Well, there are the books that I'm writing. I have plenty of time to summarize all the research I've been doing over decades, update it, coming with a lot of new stuff. So there's going to be a new book called Intuitive Machine Learning. I think that's the title. It's going to be something like that, with new approaches in machine learning, focusing on simplicity, efficiency. So a lot of the things I'm doing are related to video. So it's and images. It's one direction I'm going into it, and actually one exciting project that I have in mind would be to create those video. I can share those video, mathematical or synthetic video. I've done quite a bit of them, but I would like to add a soundtrack. And by soundtrack, I mean mathematically generated soundtrack that is related to the data that you see in the video. So I don't think anyone has ever done something like that before.
Very cool.
No, that's great. Yeah, look, really looking forward to it. And no, that's amazing. Cool. Vincent, thanks again. It's been a wonderful conversation and incredibly valuable content and incredibly valuable and thoughtful kind of answers. So thank you.
Thank you very much, Nicolai, for the invitation. It was really a great pleasure and very interesting conversation indeed. Thank you so much.
Thank you for listening to this episode of Mind the Data Gap podcast. I hope you enjoyed it as much as I did. Absolutely incredible conversation with Vincent about synthetic data, the problems it solves, the benefits it delivers, the value to the society overall. Absolutely incredible. If you found it interesting or have any topics you'd like to see discussed in the show, do let us know. We're going to be putting links in the description of the show. And please also visit our website to read the show notes. They're going to be available soon. So go to synthesized.io and you're going to see the where the podcast is. We hope you share the show with your friends and colleagues and join us by subscribing wherever you listen to podcasts as well. Thank you.